Hey everybody. So, today we're going to make a random number generator. All right. And a few things you may need is you may need a dice. You could probably find one of these in a board game. They're being cooped up. I'm sure somebody's got board game, Monopoly, something, hanging around. They just need one of those. You'll need a piece of paper you can cut up and make some numbers, 1 through 6, like that. All right. We're going to do something with that here in a minute. And you'll need a notepad that you can put on there, program, paper, and dice roll, because we're going to keep up with the numbers we generate. We're going to do this 25 times for each method. I'm obviously not going to do it on this video because that would take way too long, but you at home are going to do 25 times for each method. If for some reason you can't find a die, that's okay. Just do the paper and the program and you'll be fine. But try to do the dice if you got one. Don't skimp out on that, because it'd be kind of neat to see what it compared to the other ones. Okay, so and also if you need a pen, paper, stuff, scissors. Who don't have purple scissors? Also, you may need a hat. You don't have to have as cool a hat as me. You can just have any hat you have laying around. But if you got a cool hat, use your cool hat. So anyways, how we're going to start this is I'm going to show you kind of what my expectations are with the two physical aspects of this, because we're going to be comparing physical random numbers to digital random numbers, and we're going to kind of talk about how there's really not truly a random number. All numbers are kind of all random numbers are kind of biased. There's no actual true random out there. No matter how truly random a digital version says it is, there's aspects. It's kind of like there's no such thing as a true random heads or tails. Really, like the heads or tails, that can be like manipulated to land on whichever way they want to. So there's nothing that's truly random. So we're going to kind of look at that, and we're going to kind of compare the data and discuss what happens, and we're also going to make a program. All right, so first one we'll do is we can do the hat draw right here. So take your hat. Somebody makes a nice hat, by the way. I wear a 7 1/4 if you're wondering. Take your numbers, roll them up, drop them in there. All right, so I drop my numbers in there, shake it up. Now, one thing you may notice is you can be biased on this based on the size of your paper rolls, the size of the paper it was that you put in there, different things like that. So there are ways to manipulate this. So I'm going to just pull one out here, pull one out, unroll it, and have 6. Slide it back up, put it in here, give it a shake, pull it out, and have a 4. And I'm just going to write that down on here, and I'm going to do that 25 times. Okay, I'm not going to do that now because that would get completely ridiculous, but that's what we would do. We would do that 25 times. All right, so what we would do next is, once we got our 25 paper rolls out, we would take our die. Once again, just like the paper or coin or anything else, there's no true way of making this random, because we can manipulate the way we roll it, but we're going to just do it and hope for the best right now. So if I was to take this and roll it, I got a 1. And if I was to take it and roll it again, look at that, I got another 1. All right, so I rolled both once. So when I rolled my dice roll so far, I have a 1 and a 1. My paper, I have a 6 and a 4. So what we're going to do right quick is we're going to go ahead and make this program. And I included the program source code on Echo for you, if you can download it and look at it. I do not recommend you copying and pasting, because that will not work. Always, there's going to be some tricks to this, so you definitely need to type it, and you can use this video as a reference. So I'm going to go ahead and pull this up. Make sure that you went into your mobile apps account, and on your mobile apps account, remember the password of that is Java Swift. I believe it's all lowercase. And then when you open up Xcode, you're going to get started with Playground. You're not going to create an Xcode project. You're going to do Playground. Okay. So I would click Get Started with Playground. I'm going to start in blank right here, and I'm going to name this random number. All right. And I'm going to save that in that Xcode folder. I moved all my stuff around earlier. If y'all remember, my desktop was pretty junky. And I'm going to click create. So it's randomnumber.playground, and I created. So I start with this. Now, if you notice at the top, it says import UI kit. That works for almost everything, but random number generator is actually not included in UI kit. Okay, we're not going to talk about too much what that means right now, but I just need you to know that you have to type in import foundation. Okay, so capital F foundation. All right, and push enter. All right. So this variable string, I can delete all of that if I want to. And so I'm going to start here on line 4. Yours may be different. That's absolutely okay. But what we're going to do now is we're going to create a simulated dice roll. There's going to be some different things on here than you've seen before, but it's okay. I'm going to do them for you, and you just copy along, okay? So first thing I'm going to do is I'm actually going to create a variable, and in this variable, I want to track how many times I roll my dice, because I could go through here and I could make a really simple program that would create a dice roll and do it one and then mark my thing, do it once, mark my thing. But I'm going to make a program that does all 25 rolls in one click because, well, two other lines of code isn't enough for me to want to do that 25 times. You know what I mean? So we're going to go ahead and make this program, and it's going to roll it 25 times automatically. So I'm going to name this rolls because this is the number of rolls, and I'm going to set it equal to 0. Okay. And then I'm going to have a variable, and this variable is going to be the number for my dice. Okay. So I'm going to save variable, and I'm going to call it number. And this one I'm not going to set equal to anything because it could be anything right now. And I'm just going to declare it as an int, int. So it's an integer. Okay. So it has to be a number. Because we're going to do math with it here in a little bit. So we need to be a number, not a string or anything like that. And it's got to be a whole number because I don't know if y'all looked at one of these lately. Not a lot of decimals, okay? So what we're going to do next is you can give yourself a little space if it helps you see what's happening here. I'm going to say while, because we're going to use a while loop, because we want it to roll the dice 25 times. I'm going to say while rolls is less than 25. All the papers left my table. It's okay. While rolls is less than 25, then do something. All right, I got to put a open curly bracket there. When I hit enter, it auto generates the closed curly bracket. Okay, so I'm going to tell it every time it runs and every time rolls is less than 25 that I want rolls to add. So plus equals 1. And you want to put a semicolon there. So while rolls is less than 25, rolls plus equals 1. So every time it rolls, it adds 1 to roll, okay? Because we're trying to get 25 rolls, all right? I know that's kind of confusing, but the goal here is we want the dice to roll 25 times and us not to have to click the button 25 times. And that's what that's doing for us, okay? So the next thing we're going to do is we're going to have it randomly generate a number, which would be the numbers on our dice, okay? So we're going to say number equals int dot random, and we're going to give it a range, and this range is n colon, not semicolon, colon 1 dot 6 close semicolon. Okay, so that part may be a bit confusing, and it's okay if that bit is a little bit confusing for you. It's fine. Just type it like you see it right there, or like it is in that source code I gave you. So, and then we want it to print number. Okay, so we want it to print number. Okay, and we can take this one step further if we want to. If you want to clean this up and make it a little bit easier to look at, we can make it print. Let's see here. Print. This is roll. And when we do that, we would put a / parenthesis rolls, close parenthesis, and we would say and equals. Let's see here. It's not equals. Let's put is. This is roll blank is number blank. Okay. I think I put my slashes the wrong direction around, which is okay. We'll fix it in just a minute. Yeah, there we go. I put my slash on this one backwards. So it should be a forward slash, not a backslash. So what this is going to do, when I run it, it is going to print, this is roll 1 is blank. So the reason I did this is because I want it to be where you can determine which number roll it is. And you'll see why in just a minute, because we run this, it's just going to give you a list of 25 numbers. Okay. And that may get kind of confusing if you're copying all this down, knowing where you start and where you finish. So I wanted to make sure that you're able to determine where every roll is. Okay. So this is it. This is the whole program. The only thing I didn't put is my semicolon right there. I need to put that semicolon. And this is the whole program. You have created a dice roll if you've done this. It's right at 8 lines of code. We don't count the blank space, but it's 8 lines of code, So I'm going to go over here and I'm going to click play. If all goes well, then this should work. Okay. So I click play and boom, it plays. So if you look, this is roll 1 is 6. This is roll 2 is 1, and so on and so forth, all the way to this is roll 25 is 4. So what you would do is you would take these numbers and you would write them down on your sheet of paper. I'm just writing the top ones, but it is interesting to me to see that when I look at my top ones, I have a number from each in my program. So that's pretty cool. But you would do this 25 times for each. The fun thing about this is it automatically does it 25 times for you, and you do roughly 3 minutes worth of work. It's probably going to take you longer than that to cut out the pieces of paper, write the numbers on them, and draw them out of a hat than it is to create and run this program. The source code for this program is on there, and you have this video to walk you through. But the big takeaway here for you to remember is there is going to be some similarities between all three of these methods, but there's also going to be some rhyme or reason to all of these methods. And something you may notice is like when you look at the die in your hand, if you look at what numbers face in the top, and if you try to throw it identically, you may start seeing that same number pop up more and more and more. So kind of keep a lookout for the biases that you have in here. And if you look through here, you're going to notice, like I can tell you right now, just by looking at it, 2 pops up a lot. There's a lot of 2s in my code. And you may see something totally different in yours, because the way that this is generating a number is this computer itself can't identify what a random number is, but what it can do is it can identify like times, time of day it is down to like the millisecond, and it can use that to determine a random number. So that is how it's doing it internally. There's not actually like a little piece of this thing that says, hey, I know what a random number is. Let me spit a random number out, because there's no such thing as a random number. So that's kind of what I wanted you to look at in this exercise today is random numbers. There's going to be an assignment that follows this. And basically what you're going to do is you're going to take your notes. Everything that you're going to do today is going to be based sort of on these notes. Okay. So if you go through and you do this well and you make your good records, you're going to do this, pretty easily. This isn't going to be a hard activity to do. Next week, we're going to possibly play with doing this with names and other things, foods, things like that. And we may have you make your own program to come up with, like, I don't know, a random food that your family would eat that night or something like that. You may kind of do an inventory of your cupboard or something. But what I want you to pay attention to today is basically compare these results. What are you noticing between the 3 different methods? And what do you notice about your results in individual methods? Okay. So, random numbers are very important. Random numbers are used in just about everything programmatically wise. Like, you would use them programmatically. My goodness, I'm all over the place with my words. You would use them like casinos use them. That's how they come up with, slot results and like, video cards. Also, you would use them in your video games. If you play any kind of online game that has like a daily reward or something like that, or you win some sort of prize pack, when you open that up, there's a random number being generated based on a a percentage, and it's going to let you have like elite version, that legendary version, the rare version, or like the normal or whatever. So random numbers are a thing that you probably use way more or around you way more than you consider. And so think about it, because random numbers are very important to you. Random numbers are sometimes the difference in you getting hacked or not. Account numbers, credit card numbers. These are things that there's some method to determining them, but also there is a method of making them random that can be cheated or exploited for someone to steal or do something bad with. So random numbers are very important. Today we learned how to make a program that used them, and we got to compare them to physical versions of that. Um, Hope you're all doing well. Y'all get this turned in on Echo, and you'll be good to go. And I will see y'all next week. Bye, guys.